Okay, number 5 says find all x values on the graph of f of x equals blah 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 where the slope of the tangent line, that's fancy word for derivative, where the slope of the tangent line is 5. So that was wanting to know where the derivative equals 5. So I'm going to take the derivative, and I get 6x squared minus 2 times 3/2 is 3x to the 1 minus 4, and I'll set that equal to 5. Before we can solve this, we need to get the whole thing equal to 0. So I'm going to subtract the 5 over to the left side, minus 9. Now I can factor this. I can take a 3 out of everything, and then see if I could backwards FOIL. I get 2x and x. I get 1 and 3. So it'd be 2x minus there and a plus there. And so I have this product equal to 0. We know 3 doesn't equal 0. 2x minus 3 equals 0 means 2x equals 3, so x would equal 3/2. And here, x plus 1 equals 0 means x equals -1. So there's 2 places where the derivative equals 5. Example 6, taking the derivative and simplifying completely. So before I do that, actually, I'm going to come over here and rewrite this. When you have numbers in the denominator, you can just pull those numbers out front. So I'm doing that. And on this next part, I'm going to pull the numbers out front, but I'm going to take that x up to the top and make it x to the -8. So rewriting it is a key factor for this problem. Now taking the derivative, 4 times 2/5 is 8/5, x to the 3rd. And then -8 times 9/4 is -72 over 4, x to the -9. Simplifying completely, so the 8/5 x cubed is pretty much already where it's at. 72 can go into 4 how many times? Was that 1? 18 times. So this will be minus 18 over x to the 9th to get rid of that negative exponent. Number 7, we have lots of little individual problems here. The key to these will be rewriting them. So the first one, part A, I can bring the x up to the top. So then taking the derivative, I'm going to have -1 times 4 is -4x to the -2. Rewriting that without negative exponents is -4 over x squared. Part B, we have a number on the bottom, so I'm going to bring the number out front, and then the derivative of 1/4 x is just 1/4. Part C, it's a special derivative. It's like a to the x, so the derivative of a to the x would be a to the x times the natural log of a. This derivative will be 4 to the x times the natural log of 4. Part D is just a basic power rule. Derivative would be 4x to the 3rd. And part E, derivative of, whoa, don't know why that happened. Derivative of e to the junk is going to be e to the junk times derivative of the junk. Oh, look, there's more to this problem. So, part F, we have the natural log of junk. Derivative is going to be 1 over junk times derivative of the junk. If we want to simplify that, we can cancel it. And we get the derivative is 1 over x. Part G, we have log base 4 of x, so the derivative would be 1 over x times 1 over the natural log of the base. Number 8, find the equation of a tangent line. That's what we do on our calculator. So I'm going to pull up my calculator here. And I will go to my y equals screen. I'm going to put parentheses around my numerator. So I have the square root of 5x, close parentheses, minus 2, close parentheses around my numerator, divided by, parentheses, 4 minus x, parentheses. And I'll just hit zoom 6, my standard graph. I'm going to go to second program, choice number 5, and then I want to type in, for x equals 5, I want to type in 5, enter. And I get y equals 2.5x minus 15.5. It's the equation of the tangent line at x equals 5. Okay, now we're going to take the derivative and not simplify at all. I'm going to rewrite this first one though. 3x to the 7 plus e to the third, which is just a number by the way, minus x, all to the 1/2 power, but then all of that is to the 1/5 power. We have the 5th root of a square root. Power to a power you multiply. So this is really 3x to the 7 plus e to the third minus x raised to the 1/10. So when I go to take the derivative, I have a bunch of junk to the 1/10 power. So the derivative is going to be 1/10 junk to the negative 9/10 power. I take 1 away from that exponent. I put all the junk back in the parentheses, times the derivative of the junk. So the derivative of 3x to the 7 would be 21x to the 6th. Derivative of e to the third is just 0, because that's just a constant number, minus derivative of x is 1. And it said do not simplify at all. Don't forget you can pause this video anytime you need to. So taking the derivative of log base 2 of junk, we're going to have 1 over junk times 1 over the natural log of 2 times the derivative of the junk. And that's it. Another, do not simplify at all. I am going to rewrite this one. So rewriting it, I have 2 times 15 to the 3x. On this one, I'm going to pull my numbers out front and take that x to the top. Minus natural log of 8, which you need to make note, that's just a number, plus 9x to the half. That's just rewriting it. Taking the derivative. For the first one, the 2 just stays there. The derivative of 15 to the junk is 15 to the junk times the natural log of 15 times the derivative of the junk. Now I'm on this one. Negative 1 times 1/6 is negative 1/6 x to the negative 2. Derivative of natural log of 8 is just 0. There's no x involved. And half times 9 would be 9/2 x to the negative half. And number 12. It said don't simplify this one at all, but we're going to simplify just to practice. I know you're excited. So this is a product. That's part 1. That's part 2. So I'm going to use my product rule, 1d2 plus 2d1. Taking the derivative. 1, I'm just going to write down my 1 term. d2, I'm going to take derivative of my 2 term. Derivative of e to the junk is e to the junk times derivative of the junk. Plus 2, just write down my 2 term. d1, derivative of junk to the 6th power is going to be 6 junk to the 5th power. Put the junk in the parentheses times derivative of the junk. I'm now going to reorder. That's the calculus. I'm going to reorder this. I'm going to put my number in front and then my e and then the ugly term. Plus 6 times 3 is 18 and then the e and then the ugly term. And then I look at these two. I can't take a number out of both, but I can take an e to the 5x out of both. I have 6 of the 3x plus 4 terms over here, and I have 5 of them over there, so I could take 5 of them out. And that will leave me with 5. That's gone. One of those is left. Plus 18, that's gone, and that whole thing's gone. So I can multiply that through, and I get 15x plus 20 plus 18. So I'm going to have e to the 5x times 3x plus 4 to the 5th times 15x plus 38.